Hi again. Today we're going to take a look at the use of titration and pH and how the two of them can work together. So this is going to involve some stoichiometry as well as some knowledge of acids and bases. Let's begin with a burette filled with sodium hydroxide and down below some acid, in this case hydrochloric acid, 25 milliliters of it. I'll start by providing the equation for the neutralization. Hydrochloric acid and sodium hydroxide will exchange partners to produce sodium chloride, the salt, and water. I'm beginning with 25 milliliters of 0.1 molar acid. And in this case, I'm going to start off with essentially no base being added to the acid down below. And I'm going to try to determine the initial pH of my solution before I start adding any of the NaOH. I'm going to determine the number of moles of acid by going concentration times volume. You'll notice in this case the liters will cancel, leaving milli, the small m, and millimoles. So instead of converting it to moles, I've decided to leave my calculation in millimoles, milli standing for 10 to the minus 3. Now my number of moles of base will be exactly equal to 0 because I haven't added any yet. So the excess reagent in this case is the acid, hydrochloric acid. And I have 2.5 millimoles of that acid. The concentration of that acid is determined by taking the number of moles and dividing by the volume. Now most of you will probably note at this point in time that I could have taken that initial number and just used that to determine the concentration of the acid particle. But what I want to do here is show you a method that can be used for any volume, not just 0. So once I've determined the concentration of the hydrogen ion, it's just a small step now to determine the pH of my solution by taking the negative log of that concentration, and I get a pH of 1. So I'll place that on my graph. Now I'm going to add 10 milliliters of the base to the solution. The number of moles of acid down below remains identical because I haven't changed that. To determine the number of moles of base, again, concentration times volume, and again, I'm going to use the unit of millimoles. Now to determine the amount of the excess chemical in this case, I'm going to subtract the two. I can do this because it's a 1-to-1 ratio. So as a result, the number of moles of excess, which in this case is the acid, is 1.5 millimoles of excess acid. That can then be converted into a concentration. Now, I take the number of moles, 1.5 millimoles of acid, and divide it by the new volume. Now remember, I've added 10 milliliters to it, so the total volume is now 35 milliliters. And that gives me a concentration of 0.0429 moles per liter of the acid. That can be then used to determine the pH of my solution by taking the negative log of that value. So after I've added 10 milliliters of the base, the pH has risen slightly to 1.37. Let's go to 24 milliliters. Again, I'll determine the number of moles of base that I've added, 2.4 millimoles, and now the amount of my excess. The excess here is still the acid particle. I have 0.1 millimoles remaining. And now to determine the concentration of that particle, 0.1 over my new volume, which would be 49 milliliters. Taking the negative log of that answer, I can get a new pH of 2.7. So as I add the base, as would be expected, the pH is beginning to rise slightly. Now the next point I want to consider is when I put 25 mils in. At this point, the number of moles of base exactly matches the number of moles of my acid. We call this particular point the equivalence point, when stoichiometrically I have balanced amounts. So how am I going to determine the pH of my solution if I have no acid particles or base particles? Well, I do have water, and that water itself has an equilibrium, and that equilibrium constant is 10 to the minus 14. In water, the concentration of the hydrogen ion and the concentration of the OH ion are exactly the same, so I'm going to replace those with X. So X squared is 10 to the minus 14, giving me X, or the concentration of the acid particle, is 10 to the minus 7. And as we've seen before, if I take the negative log of that, I'll get a pH of 7. So at my equivalence point, essentially I have salty water with a pH of 7. Now again, this would have to be at 25 degrees Celsius. Let's move on. Let's add another milliliter of the base solution. So at this point I put in 26 milliliters, And now my number of moles of base starts to exceed my number of moles of acid. So the excess particle at this point in time is the hydroxide ion. I have 0.1 millimoles of excess hydroxide. I'm going to determine the concentration of that solution. Again, I have to add the volumes together. I have 51 milliliters and 0.1 millimoles on the top. That gives me a new concentration. Now, that's the concentration of the base particle. To determine the pH, I need the acid particle's concentration. So again, I'm going to turn to water's equilibrium constant to determine that. And rearranging that expression, I can get that the hydrogen ion concentration is 10 to the minus 14 divided by 0.0020. The negative log of that number gives me 11.3. That would be expected. The solution should now be basic, so the pH should be higher than 7. And I'll place that point on the graph. The last point I want to consider is when I put in 35 milliliters of my base. So I've now gone well beyond the equivalence point. I have 3.5 millimoles of the base added, and so the excess amount of base is 1 millimole. I place that 1 millimole over the new volume, which in this case would be 60 milliliters, and I get 0.0167 as the concentration of the hydroxide particle. Again, turning to the equilibrium constant for water, I can then isolate for the concentration of the acid particle. Taking the negative log of that, I get 12.2. So again, the solution continues to rise and become more basic. So what you see over here on the right-hand side is what's a classic pH curve with the titration of a strong acid with a strong base. You might find this repeated calculation to be done rather usefully with a spreadsheet, something like Excel or a Google spreadsheet, because you are essentially nesting and doing the same concentration over and over and over again. So again, I hope you found this useful, and if you did, please give me the thumbs up.